simple harmonic motion. Let us start with simple harmonic motion. First, first we will discuss what is periodic motion. Periodic motion. So what about the periodic motion? In periodic motion, the motion in which a particle or body repeats its motion after some particular time. The motion is called periodic motion. And this particular time or time interval is called time period of motion. Okay, or motion. For example, what are the example? The motion of particle, the motion of this, suppose this is what? This is earth. This is earth. The motion of earth around the sun. Suppose this is sun. This is an example of the periodic motion. And suppose this is earth and it is moving around the sun in some particular path, and it repeats its motion after some particular time interval. That time interval is 365 days. So this is the time period of this motion, isn't it? Okay, another example for periodic motion. For example, suppose this is what? The motion of simple pendulum. Suppose this is what? If we see is motion of simple pendulum about this point of suspension, if this is the point of suspension, this is an example of periodic motion. पहले point A पर था, है ना, ये point A पर था, then it will go to point B and then C, it will move to C, then it will move again to B. So this is a periodic motion, and we'll find that the time period of this type of motion is what? 2 pi root over L upon G. In this chapter, we also discuss how this time period of the motion comes. Another example of the periodic motion is the motion of a spring mass system. Suppose this is a spring mass system in which a block of mass M is connected, and if we stretch this block and it will move and to and fro about this mean position like this, from this point to this point. पहले ऐसे जाएगा, then it will move to like this, then again it will come to the mean position, then it will go to the final position. So it will move. This is also the example of periodic motion, isn't it? This is an example also periodic motion, and we'll find in this chapter that the time period of this spring mass system is root over m upon k. हम इसे बाद में prove करेंगे. What is k is the spring constant, isn't it? So this is an example of the periodic motion. Now as we have seen that in this periodic motion, any object that move around some particular path is called the periodic motion, and this periodic motion further can be divided or can be explained on the basis of the oscillation. What is oscillation? Oscillation motion. What is oscillation motion? In oscillation motion, the body or particle moves around the mean position. Moves not around, sorry. Moves to and fro about mean position. The motion is called oscillation. Oscillatory motion, isn't it? In the previous example, for example, this is only the periodic motion example, but in this case this is the oscillatory motion, because in this case ये simple pendulum, this is the mean position, और इस mean position के about to and fro motion कर रहा है ना. Similarly we see this is the spring mass system in which this is the mean position and इस mean position के about to and fro motion कर रहा है. So this is an example of the oscillation. So what are the example of the oscillation? Or the example of the oscillatory motion is the if we consider this is a spring mass system and it is moving about its mean position, then this is an example of what? Oscillatory motion. This is the mean position, isn't it? For example, the motion of the simple pendulum about its mean position. This is the mean position. It's an example of the oscillation, isn't it? So now after oscillation, there is a special type of oscillation in which the particle moves, and this motion is called the simple harmonic motion. So what is simple harmonic motion? In simple harmonic motion, or in SHM, particle oscillates about mean position such that its displacement, its acceleration is directly proportional to displacement from mean position. Also, it is opposite to the displacement. So this type of motion is called SHM. In SHM, for example, suppose this is the mean position, x is equal to 0, we can suppose, and a particle is moving such that, suppose this is the particle is moving such that the acceleration, if this is the x direction and this is the displacement x, so the acceleration of the particle is directly proportional to the displacement. Acceleration is directly proportional to displacement and opposite to the displacement. Minus sign represent, then this is displacement. Acceleration is directly proportional to minus displacement. So this is an example of simple harmonic motion. So let's see some special. In acceleration, if we remove the proportionality constant, we will have a constant which is called the omega square. Here is the constant, and omega is equal to the 2 pi by t, which is called angular frequency. So this is the equation of SHM. It can be also converted into the differential equation, that is acceleration can be written as dv upon dt is equal to minus omega square x, and dv upon dt can again be written as the double derivative of displacement minus omega square into x. So it can be further written as d square x upon dt square plus omega square x is equal to 0. This is what? This is the differential equation. Differential equation of SHM. Remember this, differential equation of SHM. However, the definition of the SHM is always to be said the acceleration is directly proportional to the displacement, opposite to the displacement. This is the differential equation. This is a special type of differential equation in mathematics. The solution of this differential equation, that is the solution of this differential equation is given is equal to x is equal to a sine omega t plus phi, isn't it? This is x. This is nothing but equal to the function of time t.